Session 12, Python Programming, Exception Handling in Python, which essentially means if there are problems, unhandled exceptions or unhandled issues or errors in the program, rather than machine messages which are hard to understand, you can give the meaningful message to the user. That's this session is all about. This is used in every language. We use in Python, we use it in Perl, we use it in other languages also. What is exception? Exception handling. Try, except, block, else, try, except, finally. What is the difference between the two? Arguments of an exception, raising an exception, user defined exceptions. In other words, this particular session is all about which helps you in giving meaningful error messages to the user in case of errors, and that is we call it as exception handling, as the name also suggests the same. Python provides two important features to handle any unexpected error in your Python program and to add debugging capabilities in them. First is, what is exception? Exception is an event which occurs during the execution of a program that disrupts the normal flow of program's instructions. In general, when a Python script encounters a situation that it cannot cope with, it raises an exception. An exception in Python is object that represents an error. That's the technical language. Now in technical term we call it as it is object that represent the error, but ultimately the meaningful name is same thing which I was talking about, the errors and logical errors which you don't expect, but user type something and instead of Python specific errors which are hard to understand, you give your own meaningful message to the user. When Python script raise an exception, it must either handle the exception immediately, otherwise it would terminate and come out of the program. How to handle an exception? If you have some suspicious code, that's what your knowledge will come into picture. You cannot say in it advance. You just put it into suspense. And if you feel that there's some code which is suspicious, which you doubt that there may be issue, there may be error in this code, you put that under a block, inside a block. So if you have some suspicious code that may raise an exception, you can defend your program by placing that suspicious code into try block. So try followed by colon, and then you put your entire code on that inside that block. After the try block, include an except statement followed by a block of code which handles the problem as elegantly as possible. So this is the segment of how do we use it. Try, and then you write your program operations here, what normally you would do. So whatever programs you have done, you can put all the programs here inside this place. And then except, exception 1. If there is an exception 1, then execute this block. So you specify multiple statements here. If you feel no, there may be another region, so you specify another region, except exception 2. Then if there is exception 2, then execute the block which is specified here. If the exception is not neither this nor this, then you use else statement, means if there is no exception, then execute this block. So when everything is good, you use this block. So if there is a problem, you execute. If problem 1, then do this. If problem 2, then do this. Else, if there is no problem, if everything is good, then execute this code segment. There are some guidelines. A single try statement can have multiple except statements. This is useful when the try block contains statements that may throw different type of exceptions. You can also provide a generic except clause which handles any exception. After the exception clauses, you can include else clause which was used, The code in the else block executes if the code in the try block does not raise an exception. So therefore this else block is a good place for code that does not need the try blocks protection, which you feel that no, if everything is good, then execute this part of the code. Let's understand the example with example. So bin user bin python 3, this is a program code. Try, now you are trying to open a file, open file, test file in write mode, fh.write, this is my test file for exception handling. Now you are opening a file. Just imagine you are working as Oracle user and you are working in a directory where you don't have write permission. So definitely you will get input output error. So accept IO error. So this is a exception you are trying to handle, that if it is input output related error, display this message to the user: error, can't find the file or can't read the data from the file. If you are working in the right directory, if you have permissions on that directory, if you feel that there should be no error, if there is no input output error, then open the file normally. In that case, you put that code in else block. Print written content to the file successfully and close the file. That means this is a successful part of the code when everything goes good. But if you feel that there may be issue, the file may not be open, you may not have write permission on the file because you are trying to open a file in a directory where you don't have permission. In that case, you use this try block. So therefore we are putting two code segments here. Try, this is the normal code. If this is the error, display this message. If there is no problem, if you feel everything is going good with the program, execute this statement. This is called exception handling. The code is available and I'm going to share the code. You're going to run the program. I don't think I need to demonstrate because this is straightforward. But yes, you have to create a scenario. You have to try to create a work in a directory, open a file in a directory where you don't have permission, like something like work as Yahoo user. Try to create a file along with a path in a root directory where you don't have write permission. So you will get this exception that will encounter. Try to open the file in the same directory where you are working. You will not get exception and the file will be created successfully. Another example, try open test file for reading. This file is test file for exception handling. Now you are trying to write in the file except input output error. Print, cannot read the file, can't find the file or read data. Means where the file, either the file does not exist or you don't have permissions on the file for reading. Else, written content in the file successfully. You are trying to write in the file. If you feel that there is an error, possibility of error, you are handling that error here by displaying a graceful message, meaningful message to the user. If there is no error, then you are writing the file data to the file and printing a meaningful message to the user. So this is called exception handling. These two examples make the little concept a little clear, but we have more to go here. The except clause with no exceptions. You can also use the except statement with no exceptions defined. Like try, you do your program here, except if there is any exception, then execute this block. Else, if there is no exception, then execute this block. So you are not naming anything, you are generalizing it. You are saying that any exception, you are generalizing all the exceptions. You don't know the name of exceptions, so you are simply putting all the possible exceptions in one single code. You don't have to define the exception, and if you don't know, you simply put this except and else. This kind of try except statement catches all the exceptions that occur. Not good practice though, because as you become more and more confident, as you start learning more and more Python, then you will know, you definitely will learn what all possible exceptions are there, and then you will start fine-tuning your program, make your program better and better. So it is not considered a good programming practice though, because it catches all exceptions but does not make programmer identify the root cause of the problem that may occur. Like if there are 5 possible regions, you cannot drill down to the exact error which might have occurred for this exception clause which you have given here. So it is better if you know 5 exceptions, you write them, and if you don't know, you write this except. Except clause with multiple exceptions, that is also possible. You can also use the same except statement to handle multiple exceptions. Like try your code here, except exception 1, exception 2, exception 3, you write all the exceptions. So you are handling multiple exceptions by specifying all of them here. So if there is any exception from the given list, then execute this block. Else, if there is no exception, execute this block. There is one more version of this try catch or try except block, that is try finally. But this finally is a very different different from else, because this is always executed whether error or no error. Means this is always displayed whether there was exception or no exception. So you can use finally block along with try block. The finally block is placed to put any code that must execute. Point to be noted, that must execute whether the try block raises an exception or not. So try, you specify exceptions, and you use finally, which will be anyway executed always. You can provide except clause or a finally clause, but you cannot provide both. That is, you cannot use either except or finally. You can use except clause or finally, but you cannot use both. You cannot use else clause as long as you are using finally. So finally is used in place of except and else. Finally is independently used. Look at the example of finally. This is our third program. You will see that in the source code. Try fh open test file in write mode. So display the message, write this content to the file, and finally print error, can't find file or read data. So whether the content is written to the file or not, this message will always be displayed. If you do not have permissions to open the file in writing mode, then this will produce this result, can't find file or read data. Even after the file is written, the content is written, this code will be executed. Some examples, same example can be written more cleanly. Try fh open test file in write mode, and we put another try finally block here. Try write to this file, and finally going to close the file and close the file, which means whether you are able to write or not, you are closing the file. It makes sense that whether you are able to write or not, this message makes some sense that you are going to close the file and you are closing the file. So displaying a message to the user, you are closing the file whether there was error or not. Then except IO error, print error, can't find file or read data. This is exception. So what you are doing here is you are putting nested conditions, that is try except, but inside that you are putting another try finally. So we can have a situation where we are putting nested conditions or nested exception handling. When an exception is thrown in the try block, the execution immediately passes to the finally block here. After all statements in the final block are executed, the exception is raised again and is handled in the except statement if present in the next higher layer of the try except statement. That is why this will handle it. If there was exception, this will be handled here also. But this way anyway, whether exception was there or not, this will be executed. We are catching the error, we are trying the error, and then we are executing that error also and handling that error gracefully. Argument of an exception. An exception can have argument, which is a value that gives additional information about the problem. The contents of the argument vary by exception. You capture an exception's argument by supplying a variable in the except clause. Like try, do your operations here, accept, exception type as argument, and now you are specifying that the code value, you can print the value of argument here, what you want to display. Meaning that example will make it more clear. once we understand this. Let's understand some more details about argument of an exception. If you are writing the code to handle a single exception, you can have a variable follow the name of the exception in the except statement. If you are trapping multiple exceptions, you can have variable follow the tuple of exception. This variable will receive the value of the exception mostly containing the cause of the exception. The variable can receive a single value or multiple values in the form of tuple, and this tuple usually contains the error string, the error number, and the error location, so that you form or you create a proper meaningful message embedding all the three values about the error. Let's understand this. This makes sense, and this example is far more easy to understand. That will make the concept clear. Program number 5. Single exception. Define a function. We are creating a function here. Temperature convert. You are passing a variable. Try except. Integer, return integer variable. Accept value error as an argument. So if there is a value error, if there is some error, right, we are passing this to our message, and we want to give a proper meaningful message along with the error name. So the argument does not contain number, and we are passing the argument here. So that this argument, whatever you give, that will appear here in the message. So call the above function here, like convert temperature xyz. Now xyz is not a number, it cannot be converted, so this is invalid. Therefore when you execute this code, you will get this meaningful message. The argument does not contain numbers. Invalid, and this is the message, the argument message. This is actually the output of this argument. So invalid literal integer with base 10 xyz, this is what you passed. So this argument is substituted here, and the meaningful message is displayed here. This message is coming because of this argument, which is actually the message returned by this value error. So if it is value error, pass this value error as a string to a print function so that we can display a meaningful message along with this error message. That makes our program much more user friendly, giving the right meaningful message to the user. Raising an exception. You can raise an exception in several ways by using the raise statement, like raise, exception, argument, trackback. Here exception is the type of exception, for example name error, and argument is a value for the exception argument. The argument is optional. If not supplied, exception argument is none. The final statement, the final argument, traceback, is also optional and rarely used in practice, and if present, it is the traceback object used for the exception. Look at the example now to make it clear. An exception can be a string, a class, or an object. We are going to understand this because we have a dedicated session on these two words here, class and object. Because that is object oriented programming, we have a comprehensive session on this particular topic. Most of the exceptions that Python core raises are classes. With an argument that is an instance of the class, defining new exceptions is quite easy. Define a function, function name, level. If level is less than 1, then raise invalid level, and you are passing the argument level. The code below to this would not be executed if we raise the exception. In order to catch the exception, an except clause must refer to the same exception thrown, either class object or simple string. For example, to capture this above exception, we must write our except clause. So try, you write your business logic, except invalid level, and exception handling code here, else rest of the code here as usual. User defined exceptions. You can define your own exceptions. That is interesting. Python also allows you to create your own exception by deriving classes from standard built-in exceptions. This is useful when you need to display more specific information when an exception is caught. Like class network error, runtime error. Define init self argument. This is the packages part, initialization and all module part. We need to discuss this part right now. You may not understand it, but that's okay because we have to discuss it separately. Self dot argument is argument. So once you define the above class, you can raise an exception. Try raise network error. That's what you define here. Bad host name. Accept network error e, and you display e dot argument. So this is actually the object of this class network error. So print e dot arguments, and this will display the actual error message. In the try block, the user defined exception is raised and caught in the accept block. The variable e is used to create an instance of the class, as I said, object or instance of the class. We will continue with the example part of the code. Let's open the first program, vi python1.py, and this is the first program we discussed. Open test file in write mode, fhwrite. This is test file for exception handling. If there is input output error, then you will get this message. Let's try to open the file with the normal permissions. We are working as root, and the test file must be created. Let me remove the existing file which I created during the testing program. Let's execute this. Python3 python1.py. Content written to the file successfully. Yes, you can try the test file and you will see the content here. So we got the content. Now let's create a error scenario for this program. I want to work as Oracle user and try to write the file in. You are writing a file with the name test file. This is my test file for exception handling. So that means open this file, write this message to the file. If you are not able to write, throw this message. It should be yow, wherever we are using this. Yow.close, because this is the file handler. We call it the file pointer or file handler. So let's copy this python1 to /home/Oracle directory, a non-privileged user. And now let's switch to Oracle user. Now we have, but this file is right now owned by root user. Let's change the permission also. Chown oracle.oracle python1.py su-oracle, and we are going to create a scenario now, opening the file python1 again, but this time I am going to change the path of this file, and I am going to try this file to be open on root directory, root, and let's say Python. This is the directory where I want to open this file. As Oracle user, obviously I don't have permission on this directory, so I should not be able to create the file. This should throw error. So let's try to execute this python3. So can't write, can't find or read data. This is exception which is thrown because it's not able to create the file. However, if I specify the test file in my home directory where I am working, /home/Oracle, then there will be no problem. If I try to execute, file written the content of the file successfully. So what we tried creating the file to some directory where the Oracle user do not have permissions. In that case, this exception was thrown. I was able to get the message. Whereas if I try to write the file in the home directory of the Oracle user where this user has the permissions, so file was created successfully. We tried two versions of the same file. Let's look at the program number 2, python2.py. This is the same thing for reading mode. If it is able to read the file, now we are going to delete the file and we are going to execute the script. Trying to open the file in read-only mode. If the file does not exist, we should get this error message. Let's see. And by the way, it will you are reading the opening the file in read-only mode. It will not be able to write the data to the file. So let's execute this. Because when you are opening the file in read-only mode, you cannot write the data. So because you are opening the file in read-only mode. In read-only mode, you cannot write the data. You understand the point? Quite simple. You are opening the file in read mode. Read means you cannot write the data to the file. So this function is not possible. You cannot write. Therefore you get this input output error. Therefore this error will be thrown, and you are writing this error to the user. So let's look at the third program now. The same test file written finally. So in this case, in both the cases, this error will be written. I mean this because it is finally, whether exception or not, this will be always executed. So let's execute this 3. So can't find file or read data always will happen because we are writing exception. So whether it is there or not, you will always get this execution. Even if the file does not exist, test file, yes, remove it, execute it, you are getting the message. Even though the file might have been created, yeah, the file is created, but still you are getting, because finally clause is executed always, whether there was exception or not. Let's look at the fourth program, program number 4. This is a exception where we are using try, except IO error, and try finally. So what we are doing here, opening the file in write mode, writing something to the file, and we are putting this into try finally block. Whether you are able to write or not, this code will always be executed, and if there was an error, this code will also be executed. So this also needs to be executed as Oracle user to verify the working of it, and as a normal user it should be able to create this file without any problem. So let's remove the file again, rm test file, yes, and now let's execute this program number 4. Going to close the file. This was anyway executed, but the file was also created. You see the file is created, cat test file is created anyway. So but let's try to create the exception part of it. So copy this file, that is python4.py, to /home/oracle, and let's change the ownership, chown oracle.oracle/home/oracle and python4.py. Now let's go to the directory su-oracle. Now I'm opening this file python4.py and trying to write the file in the root, in the directory of root user /root/python/test file. So this way it will not be able to write. This try will be executed and this will throw error, and even though error is generated, so it is going to display the message close the file, and fh close will be executed. But since there was exception is thrown, error is thrown, so this code will also be executed. Let's try python3 python4.py. Can't write the data, and we are getting the error even though the final clause that was executed. So that's what this program is all about. That's what exception handling is all about. You can practice more, you can learn more. It requires a lot of practice.